Hello, in this lecture we'll find out the area of the orange shape using two different methods. In the drawing we have square ABCD. One side of square ABCD equals to 10 units in its length. Inside this square we have two semicircles that intersect with each other. The first semicircle is CPD that intersects with the second semicircle that is APD, and they create the blue lens. And in addition we have here a quarter circle ABQD. This is the quarter circle that intersects with this semicircle, and they create the big lens. And our mission is to find out the area of the orange shape, this orange shape QPD. So in general we know that the area of the orange shape is equal to the area of the big lens minus the area of the blue lens. So I'll write it down. The area of the orange shape equals to the area of the big lens minus the area of the blue lens. Repeat again that the area of this orange shape equals to the area of the big lens minus the area of the blue lens. Okay, so in the first method we will actually find out the area of a lens. A lens is the common area that is created by the intersection of two circles or semicircles. Here the blue lens was created by the intersection of those two semicircles with each other. The common area of the two semicircles, it is actually the blue lens, while the big lens was created by the intersection of the quarter circle with this semicircle. Okay, so repeat again that a lens is a common area that was created by the intersection of the two shapes. It could be two circles or two semicircles or a quarter circle with semicircle. The common area is defined as a lens. Okay, I'll repeat again that the orange shape equals to the area of the big lens minus the area of the blue lens. So in the first method we will find out a general formula for the area of any lens, and then we'll use the general formula in order to find out the area of the blue lens, and then we'll use the same formula in order to find out the area of the big lens. We'll subtract the two areas from each other, and this will give us the area of the orange shape. But before we start to solve the question, I will clarify two concepts. The first concept is the area of a sector. The green shape is a sector. It is part of a circle. What is the area of this sector? The area of this sector equals to the ratio between the angle that is between the legs of the sector, that is theta, over the angle of the entire circle, that is 2 pi radians, or in terms of radians, in terms of degrees, 2 pi radians is 360 degrees. And then we have to multiply that ratio by the area of the entire circle. Actually, the ratio between the two angles will give us the percentage, the amount of percentage that sector occupies out of the area of the entire circle, and then we will multiply that percentage by the area of the entire circle. It gives us exactly the area of this sector. Okay, so I repeat again that the area of a sector is the ratio between the angles that are between the legs of the sector, that is here, it is theta, over the angle of a circle that is 2 pi radians, or 360 degrees in terms of degrees, and we will multiply that ratio by the area of the entire circle, that is pi r squared. This will give us exactly the area of this green sector. Repeat again, the theta over 2 pi times pi r squared is the area of this green sector. This is the first concept. The second concept is the area of a circular segment AB. The green shape is circular segment AB, and the area of this circular segment equals to the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB gives us the area of circular segment AB, that is the green shape. Okay? So, we'll start to solve the question according to the first method. I repeat again that according to the first method, we will find out the area of this lens. So we will get a general formula for the area of any length, and then we will use that general formula in order to find out the area of the big length. Then we use that same formula to find out the area of the blue length, and then we will subtract the two areas from each other, and this will give us the area of the orange shape. Okay? So here, while in the second method, we will directly calculate the area of the big length, then we will calculate the area of the blue length, and we'll subtract the two areas from each other, and this will give us the area of this orange shape. So in the first method, we just find out the area of a length that is not necessarily our two lenses, but any length. Okay? So here we have two semicircles that are perpendicular to each other, and the length is the common area that was created by the intersection of the two semicircles with each other. So here we will define the center of this semicircle as point O. We'll define the vertex here as point M, and we'll define the center of this semicircle as point N. Point N is the center of this semicircle. Point M is the point on this semicircle itself. This is exactly the definition of a radius. So we will define the radius of this semicircle as B. We'll define this point as L. N is the center of this semicircle. L is a point on the semicircle itself. This is exactly the definition of a radius. That is to say, NL is the radius of this semicircle that is equal to B units according to our definition. Likewise, we have point O that is the center of this semicircle. We have point L that is a point on this semicircle itself. Therefore, line segment OL is the radius of this semicircle that is equal to, we define the radius of this semicircle as A. So the radius OL is the radius of this semicircle that is equal to A units according to our definition. Again, we have point O is the center of this semicircle. Point M is the point on this semicircle itself. This is exactly the definition of a radius. That is to say, OM is the radius of this semicircle that is equal to A units according to our definition. Mn is the radius of this semicircle, but Mn is not only the radius of this semicircle, but it is also tangent to this semicircle at point M. Point M is the point of tendency of tangent Mn with this semicircle. Okay. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent NM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent NM will be perpendicular to the radius MO. So if NM is perpendicular to MO, it means that this angle equals to 90 degrees. This is actually rule number 1. Here we have NL. It is not only the radius, but it is also tangent to this semicircle at point L. Point L is the point of tendency of tangent NL with this semicircle. And we have here the radius OL that is drawn to the point of tendency. That is to say, it is drawn to point L. That is the point of tendency of tangent NL with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent NL will be perpendicular to the radius OL. So if NL is perpendicular to OL, it means that this angle equals to 90 degrees. Okay. In the next step, we'll join points M and L together by a straight line. And we will join points O and N together by a straight line. Here, the straight line ML divides the length into two circular segments. Okay. We have the upper circular segment ML, and we have also the lower circular segment ML. So we will find out the area of the upper circular segment. We will find out the area of the lower circular segment. We will add the two areas together, and this will be the area of this length that could be any length. Okay. So what is the area of the green lens? The area of the green lens, as I already, the area of the green circular segment, as I already showed you how to find out the area of a circular segment, it is actually equals to the area of sector MOL, the area of this sector, MOL, this is sector MOL, that I copied from the original drawing, and from the area, this is sector MOL, this is circular segment ML, so this is sector MOL, and from the area of sector MOL we have to subtract the area of triangle MOL. Here we'll subtract from the area of sector MOL the area of triangle MOL, this triangle, and this will give us the area of circular segment ML. I repeat again, the area of sector MOL minus the area of triangle MOL. This triangle will give us exactly the area of circular segment ML. Okay? So here we define angle MON as theta. Those two triangles can go into each other according to side rule. I repeat again that those two triangles can go into each other according to side rule. Here, side MO and side LO, they are both equal to A, therefore they are equal to each other. This is the first thing. In addition, we have those two sides, they are both equal to B, therefore they are equal to each other. And finally, ON is the common side that belongs to both triangles, therefore it is equal to itself. So, in conclusion, those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, those two angles are equal to each other, so if this angle equals to theta, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. So we actually found out that the angle between the legs of sector MOL, this angle equals to theta plus theta, that is 2 theta. This angle equals to 2 theta. I'll write it here. here this angle equals to 2 theta. So what is the area of sector MOL? The area of sector MOL, according to the formula that I presented to you in the beginning of the lecture, it is equal to the ratio of between the angle that is between the legs of sector MOL, that is 2 theta, over the angle that a complete circle has, this 360 degrees, or in terms of radians is 2 pi radians. 2 pi radians equals to 360 degrees. So this ratio 2 theta over 2 pi gives us the amount of percentage that the sector occupies out of the whole circle. And then when we multiply this ratio by the area of the circle, it will give us exactly the area of this sector MOL. So the area of the whole circle is pi r squared, and r equals to a, so it is pi a squared. When you multiply the ratio between the two angles by the area of the circle, it gives us exactly the area of this sector. Okay, so here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. In conclusion, the area of sector MOL equals to theta times a squared. Okay. In the first method, we don't have to find out the area of the triangle at all, because we will add the two triangles together and we will find the area of two right triangles, and it will be, we subtract the area of the two right triangles from the total area, and this will give us the area of the length. Okay, so we just have to find out the area of the sector. The area of the sector equals to theta times a squared. Now we find out the area of the lower circular segment ML. The area of the lower circular segment ML the lower orange circular segment ML equals to the area of sector LNM, the area of sector LNM this is sector LNM, minus the area of triangle MNL. It is very easy to see from the drawing that if you subtract the area of triangle MNL from the area of sector MNL, you will get exactly the area of circular segment ML, the lower circular segment ML. Okay? In order to find out the area of sector MNL, we have to find out the angle between his legs. So what is the angle between the legs of sector MNL? Here, if you focus on triangle ONM, this angle equals to theta, this angle equals to 90 degrees. In terms of radians, 90 degrees is pi over 2 radians. So this angle must be equal to 90 degrees minus theta, or pi over 2 minus theta in terms of radians. And the same thing is true in here. This angle equals to theta, this angle equals to 90 degrees, or pi over 2 in terms of radians. Therefore, this angle must be equal to pi over 2 minus theta in terms of radians. So, angle M and L equals to the sum of those two angles. That is to say, it is equal to pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi. Minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that angle M and L, this angle equals to pi minus 2 theta. Okay. This angle M and L equals to pi minus 2 theta. Therefore, the area of sector M and L will be equal to the ratio between the angle that is between his legs, that is pi minus 2 theta, over the angle of the whole circle, that is equal to 360 degrees, or in terms of radians is 2 pi radians. Again, 2 pi radians equals to 360 degrees. That ratio gives us the amount of percentage of that this sector M and L occupies out of the whole circle, and when we multiply this percentage by the area of the whole circle, that is pi r square, and r equals to b, therefore it is pi b square. This will give us the area of this sector M and L. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We'll open the brackets here. Here we have pi times b squared over 2 and here we have minus 2 theta times b squared over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And in conclusion, the area of sector M and L equals to pi b squared over 2 minus theta b squared. Okay, so the area of this length equals to the sum of the areas of the two circular segments. So here so the area of the length, that could be any length, is the sum of the areas of the two circular segments. It is equal to the area of the sector MOL minus the area of, this is sector MOL minus the area of triangle MOL so this is the area of the green upper circular segment plus the area of the lower circular segment, that is equal to the area of sector M and L this is sector M and L minus the area of triangle M and L. Triangle M and N is actually, this is triangle M and N, this is triangle M and N. I repeat again that the area of this length equals to the sum of the areas of the two circular segments. This is equals to the area of the green circular segment, that is equal to the area of sector MOL minus the area of triangle MOL plus the area of the lower circular segment, that is actually equals to the area of sector M and L minus the area of triangle M and L. Okay. So actually the area of the length equals to the area of sector MOL, that is equal to theta times A square plus the area of sector M and L that is equal to pi B square over 2 minus theta times B square. So this is the sum of the sum of the areas of the two sectors, and we have to subtract the sum of the areas of the two triangles. Okay, so minus the area of the two triangles. Triangle MOL plus the area of triangle MNL. So we have to subtract from the sum of the areas of the two sectors the sum of the areas of the two triangles. So we will combine the two triangles together, and we will get that we combined the two triangles together, MO equals to A, OL equals to A, MN equals to B, inside NL also equals to B. Angle OMN equals to 90 degrees. And angle OLN also equals to 90 degrees. In the next step, we will join points N and O together by a straight line. By joining points N and O by a straight line, we created here two right triangles. We created the right triangle OMN, the green right triangle OMN, and we also created the orange right triangle ONL. So the sum of the areas of those two right triangles is equal to the sum of the areas of those two triangles that are not right triangles. It is equal to the sum of the areas of those two right triangles. So what is the area of the green right triangle? Is equal to the base of the triangle times the height to the base over 2. That is A times B over 2. This is the area of the green right triangle. And what is the area of the orange right triangle? It is also A times B over 2. So the sum of the areas of those two right triangles is A times B over 2 plus A times B over 2. A times B over 2 plus A times B over 2 equals to 2 times A times B over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. and it is equal to AB. So we actually found out that the sum of the areas of the two triangles is A times B. So we have to subtract from the sum of the areas of the two sectors the sum of the areas of those two triangles, and the sum of the areas of those two right triangles is A times B. So we subtract AB from this expression, and this gives us the area of this lens. Okay, so the area of this lens equals to theta times A square plus pi B square over 2 minus theta B square, that is the sum of the areas of the two sectors, minus the sum of the areas of the two triangles, that is minus AB. AB is the sum of the areas of the two triangles, therefore minus AB is we subtracted the sum of the areas of the two triangles from the area of the two sectors, so it is equal to this expression minus AB. Okay, so in conclusion, we found out that the area of the lens, that could be any lens, the area of the lens is equal to theta A square minus theta B square plus pi B square over 2 minus AB. That is the area of this lens, that could be any lens. Now we'll take theta as a common factor from out of those two expressions, and we will get that the area of the lens, so theta is a common factor. What is left from this expression after we took from it theta as a common factor? What is left is actually A square. And what is left from this expression after we took from it theta as a common factor? What is left is actually minus B square plus pi times B square over 2 minus AB. Okay, so that is the area of a lens. Now we'll find out the value of theta, because we want to create a formula that the only missing variable in the formula will be A and B, that are the radii of the two shapes that intersect with each other. So in order to find out the value of theta, I'll copy the right triangle MON that includes angle theta, and we'll find out the value of angle theta. So this is the right triangle MNO. This is angle theta. This angle equals to 90 degrees. We also know that MO equals to A is the radius of this semicircle, while MN equals to B, it is the radius of this semicircle. So here we get that tangents theta in the right triangle MNO, tangents theta equals to MN over MO. MN over MO. MN equals to B. MO equals to A. So in conclusion, I found out that tangent theta equals to B over A. But we want to find out the value of theta itself, not the value of tangent theta. So in order to find out the value of theta itself, we will operate the opposite function of tangents on the result, and this operation will give us the value of theta itself. So the opposite function of tangents is tangents minus 1. We will operate it on the result, that is B over A, and this will give us the value of theta itself. So in conclusion, theta equals to tangents minus 1 of B over A. So we substitute theta by tangents minus 1 of B over A in this formula. And we will get that the area of any length of this length, that could be any length, is equals to theta. We already found out that theta equals to tangents minus 1 of B over A, and we have to multiply it by A squared minus B squared plus pi B squared over 2 minus AB. So we actually found out a formula for the area of any length. This is the formula for the area of any length. We'll use this formula in order to find out the area of the big lens. Then we use the same formula in order to find out the area of the blue lens. We subtract the two areas from each other, and this will give us the area of the orange shape. So first of all, we will find out the area of the big lens by using this formula. What is the area of the big lens? The area of the big lens was created by the intersection of the quarter circle with this semicircle. And we know that the radius of the quarter circle equals to 10 units, so A equals to 10. It is the radius of the quarter circle. And the radius of this semicircle, actually it is the intersection of the quarter circle with this semicircle that created this big circle. So we know that the diameter of the semicircle equals to 10 units, therefore the radius will be equal to 5 units. So B equals to 5. Okay. Now we'll put the value of A and B inside this formula. This formula gives us the area of a lens, that could be any lens. Okay, so we use this formula in order to find out the area of the big lens. Here A equals to 10 and B equals to 5, so we get it here that it is equals to tangents minus 1 b is 5, a is 10, so 5 over 10 is 1 half, 1 half is 0.5 times a squared minus b squared. A is 10, so a squared is 10 squared minus b squared. B is 5, so b squared is 5 squared. Plus pi b squared over 2. Pi is 5, so pi squared is 5 squared over 2 minus a times b. Minus 5 times b is 5 and a is 10, so it is minus 5 times 10. Okay, so the area of the big lens equals to this expression is equal to 10 square is 100 minus 5 square is 25. 100 minus 25 is 75, so this expression in total equals to 75 times tangents minus 1 of 0.5 plus 5 square is 25. 25 over 2 is 12.5. So in conclusion, this expression equals to 12.5 pi. Minus 5 times minus 10 is minus 50. So in conclusion, we found out that the area of the big lens equals to this expression, 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. This is the area of the big lens. In the next step, we'll find out the area of the blue lens. This is, as you can see from the drawing, the blue lens, it is a common area of the two semicircles that intersect with each other. The blue lens was created by the intersection of the two semicircles with each other. So actually, we know that the radii of the two semicircles, it is equal to 5 units. So here A equals to 5 and B also equals to 5. So we just have to put the values of A and B in the general formula for the area of a lens, and we will find out the area of the blue lens. So the area of the blue lens will be equal to according to this formula, it is tangents minus 1 of b over a. B is 5, a is 5, and 5 over 5 is 1 times a squared minus b squared. A is 5, so a squared is 5 squared minus b squared. B is also 5, so it is minus 5 squared. 5 squared minus 5 squared is 0. So actually this expression equals to 0 plus pi b squared over 2. b is 5, b squared is 25. 25 over 2 is 12.5, so in conclusion this expression pi b squared over 2 equals to 12.5 pi minus AB. A is 5, B is also 5, 5 times 5 is 25. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. In the next step, we subtract the area of this blue lens from the area of the big lens, and this will give us the area of the orange shape. I repeat again, the area of the big lens minus the area of the blue lens will give us the area of this orange shape dpq. Okay, so the area of the orange shape is equal to the area of the big lens minus the area of the blue lens. That is to say, the area of the orange shape equals to the area of the big lens, and we have already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50 from the area of the big lens. We subtract the area of the blue lens, and we already found out that the area of the blue lens equals to, so it is minus the area of the blue lens, that is equal to 12.5 pi minus 25. So here we will open the brackets, and we will get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi minus the area of the blue lens. So we will open the brackets here. So here we will get minus 12.5 pi and here we have minus, and minus is plus. Minus 25 is plus 25. So actually found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5. Here we have minus 50 plus 25 is minus 25. And we also have here 12.5 pi minus 12.5 pi is 0. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. You know that the value of tangents minus 1 of 0.5 it is equal to 0.46. Therefore, we get that the area of the orange shape equals to 75. Tangents minus 1 of 0.5 is 0.46 minus 25. $75 times 0.46 is 34.77 minus 25. 34.77 minus 25 is 9.77. So in conclusion, I found out that the area of the orange shape equals to 9.77 square units. Okay. Here, the area of this orange shape is equal to 9.77 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this orange shape according to the second method. In the second method, we will not use a general formula for the area of any length, but we will directly calculate the areas of the area of the blue lens. We'll calculate the area of the big lens and we'll subtract one from each other. In this way, we'll get the area of this orange shape. Okay. I repeat again. In the second method, we'll calculate directly the area of the big lens, then we'll calculate the area of the blue lens, and we'll subtract the area of the blue lens from the area of the big lens, and this will give us the area of this orange shape. Okay? First of all, we will find out the area of the blue lens, and then we'll find out the area of the big lens. Okay? Here we can use this drawing from the first method, because A could be equal to 5 units, that is the radius of this semicircle, and B also could be equal to 5 units, that is also the radius of this semicircle. Okay? Now, our mission is to find out the area of this blue lens. Okay? The area of the blue lens. This is the blue lens, and we want to find out the area of the blue lens. I will remind you that the blue lens was created by the intersection of the two semicircles with each other. Those are the two semicircles. The radius of each semicircle is equal to 5 units. The two semicircles intersect with each other at 90 degrees, that is to say they are perpendicular to each other. This angle equals 90 degrees, it is a right angle, as I've already explained in the first method. This angle also equals to 90 degrees. The area of this blue lens, here Mn equals to 5 units, Mo equals to 5 units, N equals to 5 units, and N equals to 5 units. So we will find out the area of this circular segment. And because of the fact that the two radii, they are both equal to 5 units, we'll just multiply the area of this circular segment by 2, and this will give us the area of the blue lens, because those two shapes, they are identical. That is to say, they have also the same area. So if we multiply the area of this green circular segment by 2, we'll get the area of the blue lens. So what is the area of this green circular segment? the area of this circular segment will be equal to so here we want to find out the area of the upper circular segment of the big lens, the shape in the green color. Circular segment ML. The area of circular segment ML will be equal to the area of sector MOL is equal to sector MOL minus the area it is actually equals to sector MOL minus the area of triangle MOL minus the area of triangle MOL. This angle equals to 90 degrees. This angle also equals to 90 degrees. Each side of this sector equals to 5 units. Each side of the triangle equals to 5 units. So this is sector MOL. Actually, sector MOL, it is a quarter circle. It is a quarter circle, therefore the area of any quarter circle it is equal to the area of the circle over 4. So the area of this circle is pi r square and r equals to 5, so it is pi times 5 square. And we have to divide it by 4 in order to get the area of the quarter circle. So the area of the quarter circle equals to pi times 5 square over 4. This is a right triangle, and the area of a right triangle is 5 times 5 over 2. Now, in order to get the area of the lens, we have to multiply the area of circular segment ML, that is equal to this expression by 2, and this will give us the area of the blue lens. Okay, so here the area of the blue lens, this is the blue lens, area of the blue lens will be equal to 2 times the area of circular segment ML. So it is 2 times pi times 5 square over 4 minus 5 times 5 is 25 over 2. Okay. So the area of the blue lens equals to this expression. Here we'll open the brackets and we'll get that 2 over 4 times 25 minus 2 times 25 over 2. So it is equal to, here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. 2 over 2 is 1, so in the numerator we left only with 25. Here we have also pi. In the numerator we left only with 25 pi. And there 4 over 2 is 2. So this expression in total equals to 25 pi over 2. And there we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So we left here with minus 25. So in conclusion, the area of the blue lens is equal to 25 over 2 is 12.5. So this expression equals to total to 12.5 pi minus 25. Okay. So you can write here that the area of the blue lens equals to 12.5 pi minus 25 square units. Found out the area of the blue lens. The area of the blue lens equals to 12.5 pi minus 25. So we finished with the first step. In the second step, we will find out the area of the big lens. We will find out directly without any formulas the area of this big lens. It is very easy to see from the drawing that the big lens was created by the intersection of the quarter circle with this semicircle. The intersection of this quarter circle with this semicircle created the big lens. So here you can see the intersection of this quarter circle with this semicircle created this big lens. So here is equal to 10 units. Here this will be the point O, the point M. We join the two centers together by a straight line. Here point M is the center of the semicircle, point L is the point on the semicircle itself. Therefore ML is the radius of the semicircle, that is equal to 5 units. Again, here point M is the center of this semicircle, point N is the point on the semicircle itself, that is to say MN is the radius of this semicircle, that is also equals to 5 units. But here MN, it is also tangent to this quarter circle at point N. Point N is the point of tangency. Of tangent MN with this quarter circle. And we have here the radius ON that is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent MN with this quarter circle. Whenever you have a radius that is drawn to the point of tangency, then tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. Here point O is the center of the quarter circle, point L is the point on the quarter circle itself, that is to say OL is the radius of the quarter circle, that is equal to 10 units. But L, it is also the point of tangency, of tangent ML with this quarter circle. Here we have the radius OL that is drawn to the point of tangency, that is to say it is drawn to point L, that is the point of tangency of tangent ML with this quarter circle. That whenever you have a radius that is drawn to the point of tangency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals to 90 degrees. So here we have those two triangles can go into each other according to side rule. Why? Those two sides, they are both equal to 10 units, therefore they are equal to each other. Those two sides, they are both equal to 5 units, therefore they are equal to each other. And side OM is a common side that belongs to both triangles. So therefore those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we conclude that those two angles equal to each other according to the rule that corresponding angles and congruent triangles are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta because of the fact that they are equal to each other. Okay? So here, this angle equals to theta, this angle equals to 90 degrees. Therefore, this angle will be equal to pi over 2. 90 degrees is pi over 2 minus theta. Likewise, in triangle OLM, this angle equals to theta, this angle equals to 90 degrees, that is pi over 2. Therefore, this angle will be equal to pi over 2 minus theta. We'll join points N and L together by a straight line. So our mission is to find out the area of the big lens. So first of all, we'll find out the area of the upper circular segment. In the next step, we'll find out the area of the lower circular segment. That will give us the area of the big lens. So in the first step, we'll find out the area of the upper circular segment. Okay, what is the area of the upper circular segment? The area of the upper circular segment NL, the green shape, it will be equal to the area of sector NOL, the area of this sector. This is sector NOL. Minus the area of triangle NOL. This is triangle NOL. N equals to 10 units, LO equals to 10 units. This is circular segment ML. This is sector NLO. This is triangle NLO. Okay, so what is the area of sector NLO? It is equal to the ratio between the angle that is between his legs, that is 2 theta, over 2 pi, that is the angle of the whole circle. That ratio gives us the amount of percentage that this sector NLO occupy out of the whole circle, and if we multiply it by the area of the circle, that is pi r square, and r equals to 10, so it is pi times 10 square. It will give us exactly the area of this sector NLO. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So this expression equals to 10 square is 100 times theta. 100 theta, and we have to subtract also from it the area of triangle NLO, the area of this triangle NLO. It is the multiplication of the two sides by each other, 10 times 10, minus sinus times sinus, the angle between the two sides, that is sinus 2 theta over 2. Okay, so in conclusion, we found out that the area of the upper circular segment of the big lens NL is equals to 100 times theta minus 10 times 10 is 100, and 100 over 2 is 50. So it is 50 times sinus 2 theta. So in conclusion, we found out that the area of the upper circular segment NL of the big lens is equal to 100 theta minus 50 times sinus 2 theta. In the next step, we'll find out the value of theta and the value of sinus 2 theta. In order to find out the value of theta, I will draw the right triangle MNO that contains angle theta, and we derive the value of angle theta and the value of sinus 2 theta from this right triangle. Okay? So our mission is to find out the value of theta and the value of sinus 2 theta. This is triangle NMO. In triangle NMO, sinus theta equals to NM over NO. That is to say, NM here, you know that NM equals to 5 units, NO equals to 10 units. You can see it from this drawing. So NM equals to 5 units, NO equals to 10 units. So in conclusion, we found out that sinus, it is actually tangent theta. Tangent theta. Here, tangent theta, it is very easy to see from the drawing. Tangent theta equals to NM over NO. Tangent theta equals to NM over NO. NM equals to 5, NO equals to 10. So in conclusion, we found out that tangent theta equals to 5 over 10. 5 over 10 is 1/2, that is 0.5. But we are not interested in tangent theta, but in theta itself. So in order to find out the value of theta itself, we'll operate the opposite function of tangents on the result, and this will give us the value of theta itself. So theta itself will be equal to tangents minus 1 of 0.5. We operated the opposite function of tangents on the result, and we got the value of theta itself. We found out in conclusion that theta equals to tangents minus 1 of 0.5. Okay. In the next step, we will find out the value of sinus 2 theta. So I will draw triangle NOM here. So here we will find out the length of the hypotenuse OM by implementing the Pythagoras theorem on the right triangle NOM, this right triangle. So the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OM squared equals to NO squared plus NM squared. So OM squared equals to NO squared. NO is 10, so NO squared is 10 squared, that is 100, plus NM squared. NM equals to 5, so NM squared is 5 squared, that is 25. So in conclusion, we found out that OM squared equals to 100 plus 25 is 125. We will take a root out of this equation and we will get that OM equals to the square root of 125. And 125 is 25 times 5. So we substituted 125 by 25 times 5. We took a root out of this equation and found out the square root of 25 is 5. Inside the root we left only with 5. So we found out that the hypotenuse OM equals to 5 times square root of 5. Now our mission is to find out the value of sinus 2 theta. We have the trigonometric identity that states that sinus 2 theta equals to 2 times sinus theta times cosine theta. That is to say, sinus 2 theta equals to 2 times sinus theta. What is the value of sinus theta? From this drawing from the triangle NOM, it is very easy to see that sinus theta equals to NM over OM. Again, sinus theta equals to N here. Sinus theta in the right triangle NOM equals to NM over OM. That is to say, sinus theta equals to NM, that is 5, over OM. OM equals to 5 times square root of 5. So in conclusion, we found out that sinus theta equals to 5 over 5 times square root of 5. And what is the value of cosine theta? From the drawing it is very easy to see that cosine theta in the right triangle NOM equals to ON over OM. So it is ON that is 10 over OM that is 5 times square root of 5. So in conclusion, we found out that cosine theta equals to 10 over 5 times square root of 5. So here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So here in the numerator we have 2 times 10. In the denominator we have square root of 5 times square root of 5, that is 5 times 5. Here 10 over 5 is 2, and 2 times 2 is 4. In the denominator we left only with 5. So actually, in conclusion, we found out that sinus 2 theta equals to 4/5. So I write it down. In conclusion, we found out that sinus 2 theta equals to 4/5, and theta itself equals to tangents minus 1 of 0.5. And we have already found out that the upper circular segment of the big lens the area of the upper circular segment of the big lens NL, this is the upper circular segment NL of the big lens, upper circular segment, and the area of this circular segment NL, it is equal to 100 times theta minus 50 times sinus 2 theta. Now we substitute theta by tangents minus 1 of 0.5, and we substitute sinus 2 theta by 4/5. And we will get that the area of the upper circular segment NL equals to 100 times theta, and theta equals to tangents minus 1 of 0.5 minus 50 times sinus 2 theta. And we already found out that sinus 2 theta equals to 4/5, so we substitute sinus 2 theta in this equation by 4/5. So here we get that the area of the upper circular segment NL is equal to 100 times tangents minus 1 of 0.5, that is the opposite function of tangents, minus here 50 over 4 is 10, and 10 times 4 is 40. So in conclusion it is minus 40. We actually found out that the area of the upper circular segment of the big lens, it is equal to 100 times tangents minus 1 of 0.5 minus 40. In the next step, we will find out the area of the lower circular segments. And then we will add the two areas together. It will give us the area of the big lens. Okay. So here our mission is to find out the area of this shape, that is the lower circular segment of the big lens. Okay. We have already found out that this angle equals to 90 degrees. It is a right angle. 5. we have already found out that angle NMO equals to theta over 2 minus pi over 2 minus theta. Angle OML also equals to pi over 2 minus theta. So actually in total, the size of angle NML, it is equal to the sum of those two angles. This is pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, is minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle NML equals to pi minus 2 theta. Okay. So what is the area of the lower circular segment NL? The area of the lower circular segment NL the area of the lower circular segment NL, the green shape, is equal to the area of sector NML, this sector, the area of sector NML here NM equals to 5, ML equals to 5, and this angle equals to pi minus 2 theta minus the area of triangle NML. Okay. So what is the area of sector NML? The area of sector NML equals to the angle between his legs is pi minus 2 theta over 2 pi times the area of the circle, that is pi r square, and r equals to 5, so it is pi times 5 square. So here we have pi in the numerator and pi in the denominator, so 5 will get cancelled. We'll open the brackets here and we'll get that pi 5 square is 25, so it is 25 pi over 2 minus 2 theta over 2 times 25. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, this expression equals to 25 pi over 2 is 12.5 pi, 12.5, and this expression in total equals to 12.5 pi minus 25 theta and we have to subtract from the area of the sector NML the area of triangle NML. The area of triangle NML, it is equal to the multiplication of the two sides together by each other, 5 times 5, times sinus the angle between the two sides, that is pi minus 2 theta, all divided by 2. So in conclusion, I found out that the area of the lower circular segment NN equals to 12.5 pi minus 25 times theta, Five times 5 is 25. So it is 25 over 2. Here we know that sinus pi minus 2 theta equals to sinus 2 theta. And we have already found out that sinus 2 theta equals to 4/5. So in conclusion, we found out that the area of the lower circular segment NL of the big lens equals to 12.5 pi minus 25 theta minus 25 over 2, and sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. So it is equal to 12.5 pi minus 25 theta. Here we have 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10. It is minus 10. So in conclusion, we found out that the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 theta minus 10. Now we will add the upper circular segment to the lower circular segment, and this will give us the area of the big lens. Okay. I'll repeat again that the area of the big lens equals to the area of the upper circular segment NL plus the area of the lower circular segment NL. Okay. The area of the lower circular segment NL equals to 12.5 pi minus 25 theta minus 10. And the area of the upper circular segment NL equals to 100 times tangents minus 1 of 0.5 minus 40. So we'll add the area of the two circular segments together and we'll get the area of the big lengths. But first of all, so here theta equals to tangents minus 1 of 0.5, so this expression equals to 25 times tangents minus 1 of 0.5 minus 10 plus 12.5 pi. This is the area of the lower circular segment, while the area of the upper circular segment equals to 100 times tangents minus 1 of 0.5 minus 40 plus, so here we have 25 times tangents minus 1 of 0.5 and we have 100 times tangents 1 minus 25 of 0.5, and here it is minus 25 tangents minus 1 of 0.5. So here 100 minus 25 is 75. So it is 75 times tangents minus 1 of 0.5. Here we have minus 40 plus minus 10 is minus 50. And we have also here plus 12.5 pi. So in conclusion, we found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Okay, so here we have to add the area of the big lens to the area of the actually we have to subtract from the area of the big lens the area of the blue lens. What is the area of the blue lens? We have already found out that the area of the blue lens equals to 12.5 pi minus 25. So from the area of the big lens, we subtract the area of the blue lens, and this will give us the area of the orange shape. I repeat again that the area of the big lens minus the area of the blue lens will give us the area of the orange shape. The area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay? So the area of the orange shape is equal to the area of the big lens. We already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. And we have to subtract from the area of this big lens the area of the blue lens. So it is minus the area of the blue lens, and the area of the blue lens equals to 12.5 pi minus 25. So here we'll open the brackets and we'll get that the area of the orange shape, in conclusion, it is equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Here we will open the brackets and we get here this is equals to minus 12.5 pi, and here we have minus and minus is plus, so it is minus 25, it is plus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5. Here we have 12.5 minus 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled, and minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. Okay. And we know that tangents minus 1 of 0.5, it is equal to 0.46. So we found out that the area of the orange shape, in total it is equal to 75 times tangents minus 1 of 0.5, and tangents minus 1 of 0.5 equals to 0.46 minus 25. $75 times 0.46 is 34.77 minus 25, 34.77 minus 25, it is equal to 9.77. So in conclusion, we found out that the area of the orange shape equals to 9.77 square units. Okay. So we finished with the second method. In the next step, I'll summarize the lecture. We'll start with the first method. So in the drawing, we have a square ABCD. One side of square ABCD equals to 10 units. Inside the square we have two semicircles that intersect with each other, and they create the blue lens. and we also have the quarter circle that intersects with this semicircle, and they create here the big lens. And our mission is to find out the orange shape. It is very easy to see that this orange shape equals to the area of the big lens minus the area of the blue lens. Okay. The area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay. So in the first method, we'll create a general formula for the area of any lens, and then we'll use this general formula in order to find out the area of the big lens. Then we'll use this formula in order to find out the area of the blue lens, and we'll subtract the two areas from each other, and we'll get the area of the orange shape. Okay, but before that, I explain to you what is the area of a sector. Or the area of a sector equals to the area of the size of the angle between the legs of the sector over the angle that is the angle of the whole circle itself, that is 2 pi radian, so in terms of degrees is 360 degrees. So that ratio between the two angles gives us the amount of percentage that the sector occupy out of all the circle, and then we will multiply it by the area, this percentage by the area of the whole circle. It will give us exactly the area of this sector. So theta over 2 pi times pi r squared equals to the area of this green sector. And then I explain to you what is the area of circular segment AB in the green shape. The area of the circular segment AB equals to the area of sector AOB minus the area of triangle AOB. If you subtract from the area of sector AOB the area of triangle AOB, we will get exactly the area of this circular segment AB. Okay, so here in the first method we create general formula for the area of any lens. So here we have two semicircles that are perpendicular to each other, and they create this lens. This lens is the common area of the two semicircles. So a lens is the common area that was created by the intersection of two circles or semicircles or quarter circles. Okay. So here we have we want to find out the area of this lens. So we divided the lens into two circular segments. We'll find out the area of the upper circular segment, we'll find out the area of the lower circular segment, we'll add the two areas together. This will be the area of this lens that could be any lens. So what is the area of the upper circular segment? The green circular segment. The area of the green circular segment equals to the area of sector MOL minus the area of triangle MOL. Okay. Here, in order to find out the area of sector MOL, we have to find out the size of the angle between his legs. So we know that those two triangles can point to each other according to side rule. Here those two sides are both equal to A, those two sides are both equal to B, and we have the common side ON. So if this angle equals to theta, then this angle must be also equal to theta according to the rule that corresponding angles can congruent triangles are equal to each other. So if this angle equals to theta, then this angle also equals to theta. So the angle between the legs of sector MOL is equal to theta, to 2 theta. We divided 2 theta by 2 pi and we multiply it by the radius of this circle, that is pi square. Here theta, we have pi from this both sides of the equation, so pi will get cancelled. So in conclusion, we found out that the area of sector MOL equals to theta a square. Then we found out the area of the lower circular segment. The area of the lower circular segment equals to the area of sector MNL minus the area of triangle MNL. The area of sector MNL equals to the angle between its legs, that is pi minus 2 theta over 2 pi times pi b squared, that is the area of this circle. So in conclusion, the area of sector MNL equals to pi b squared over 2 minus theta b squared. Okay, and actually we have the area of this length equals to the area of the upper circular segment, that is the area of sector MOL minus the area of triangle MOL, plus the area of the lower circular segment, that is the area of sector MNL minus the area of triangle MNL. And the area of the two sectors, they are equal to theta a square plus pi b square over 2 minus theta b square. And we have to subtract from the area of the sum of the areas of the two sectors the sum of the areas of the two triangles. In order to find out the area of the two triangles, we combine them together. We join points O and N together by a straight line. In this way, we created two right triangles. The area of those two right triangles is AB. So in conclusion, the area of this length equals to the sum of the areas of the two sectors, that is this expression, minus the area times the sum of the areas of those two triangles, that is equal to AB. Okay? So the sum of the areas of the sector minus the sum of the areas of the two triangles equals to this expression. And here we found that it is equal to theta times a square minus b square plus pi b square over 2 minus ab. From this triangle we found out the value of theta. We substituted we found out the value of theta, so we substitute theta by tangent minus 1 of b over a. So we got here a general formula to find out the area of any length. Then we use this general formula in order to find out the area of the big length. And we use the same formula in order to find out the area of the big length, and we use the same formula in order to find out the area of the blue length. We subtract the two areas together from each other, and found out that the area of the blue shape, the area of the orange shape, equals to 9.77 square units. Then in the second method, we didn't create general formula for the area of a length, but we calculated directly the two areas, the area of the big length. Then we calculated the area of the big length, the area of the big length, and we calculated the area of the blue length, and we subtracted the two areas from each other, and we got the area of this orange shape. Okay, so here, so first of all we found out the area of the blue lens. The area of the blue lens equals to 12.5 pi minus 25 pi. Then, in the first step, we found out the area of the big lens. The area of the big lens consists of two areas. It is the area of the upper circular segment plus the area of the lower circular segment. So in the first step, we calculated the area of the upper circular segment, and the area of the upper circular segment of the big lens is equal to it is equal to 100 times theta minus 50 times 100 times minus 1 of 0.5 minus 40. Then we actually calculated the area of the lower lens, the area of the lower circular segment of the big lens, and the area of the lower circular segment of the big lens is equal to 12.5 pi minus 25 theta minus 10. Then we added the two areas together. The area of the upper circular segment plus the area of the lower circular segment gives us the area of the big lens. Then we subtracted the area of the orange shape equals to the area of the big lens minus the area of the blue lens. So the area of the big lens equals to this expression, the area of the blue lens equals to this expression. We subtracted the two expressions from each other, and we found out finally that the area of the orange shape equals to 9.77 square units. Okay, so in both methods we found out that the area of this orange shape equals to 9.77 square units. Okay, so I'll summarize again the two methods. According to the first method, in order to find out the area of this green shape, first of all, the area of this orange shape equals to the area of the big lens minus the area of the blue lens. And in order to find out the area of this orange shape, I presented to you two methods. In the first method, we found out the area of a lens that could be any lens, and we use that formula in order to find out the area of the big lens. Then we use the same formula in order to find out the area of the blue lens. We subtracted the two areas from each other. In this way we got the area of this orange shape. While according to the second method, we didn't create any formula to find out the area of the lens, but we directly calculated the area of the blue lens, then we calculated the area of the big lens, we subtracted the two areas from each other, and we found out that the area of the orange shape in both methods, it is equal to 9.77 square units. Okay? Thank you very much.